Jr. in the movie Limitless, okay? But this is not like the movie Ryan Gosling Jr. is in, because Ryan Gosling Jr. Because this is, oh, it's not, I'm thinking of the other guy, Jr. Robert Downey Jr. Ryan, because this is not limitless, this is limitful. Because we're going to be talking about limits. How appropriate, huh? Okay, so introduction to limits. There you go.
Was it Ryan Gosling or Matthew McConaughey?
No, that was Limitless was Ryan Gosling. I would have known Matthew McConaughey. If my wife would have watched it if it was Matthew McConaughey, because she loves him. So in the movie it's Matthew McConaughey, even if it's really bad. Oh, it's got him. Oh, yeah. Okay, even that movie about where they. Oh, The Martian. The Martian. That was Matthew McConaughey. She also had Matt Damon. He played Santa. Right? Okay. Introduction to limits. Here we go. You have 20 feet of fence. You want to make rectangular closure. Find the dimensions that will give you the maximum area. Okay? So you don't have to write this down, but this is kind of an intro to how they introduce this section. So if I wanted to find out how they maximize the area, you would call this like the length and this like the width. And if I want to maximize the area is what? What's the area? Length times width, right? Am I recording right now? I gotta make sure I'm recording. I'm recording. I've been talking about nothing for 1 minute and 45 seconds. Okay. So, and then you also know that the perimeter is equal to what?
20.
Yeah, it's 20, and that's also can be expressed in terms of L and W as 2L plus 2W. Now I could do some math, which you will have to do once you get to a, we've actually done this problem before. You could divide everything by 2 here. Divide everything by 2, divide everything by 2. And you get 10 is equal to L plus W. And then you can solve for W. So W is equal to 10 minus L. And then you could take that and you can plug that into the original equation. Now this is not a limit, well it's kind of like a limit problem, but it's just kind of introduce the idea of limits. I'm not going to give you one on your test, I don't think like this. But so then what you do is you find that the area is equal to L times 10 minus L, right? And what you're trying, and this is equal to 10L, excuse me, 10L minus L squared. And then this represents the area of your function. So the area is 10L minus L squared. And I want to see where this reaches a maximum. So what's one way to do that? How can I figure out where it reaches a maximum? Ah, very good. So Francesco knows this makes a parabola and find the vertex of a parabola. One technique that we're going to use in this class is to use your calculator, okay? And you can find limits using your calculator by looking at a table of values. So if you're not familiar with how to mess with your table, okay, we could find the vertex of the parabola. We're not going to do that right now. I'm just going to plug in y equals this equation, which is 10, instead of L, I'm going to put in x, minus x squared, okay? And if I look at the table of values, I'm going to guess, okay? Anyone want to guess where the maximum is going to occur?
5.
How do you know that?
I got it.
Oh, because Francesco found the vertex of that route. But if I did not, if I did not know that it was at the vertex, yes, John?
Can you get like the maximum area when it's like the sides are closest to each other? So it's 5 times 4.
That 5 times 4, well, that's the perimeter, right? You're thinking about?
Yeah.
Yeah. Oh, so when the sides are closest to each other?
Yeah, you're like 5 times 5.
5 times, well, it'd be 5 plus 5 plus 5 plus 5, which would make 20, right? So that's when they'd be closest to each other,
It's a square.
right? It would be a square. it would be a square, but you have to be careful with that because that's not always the case. Like if you've only got 3 sides, you know, it wouldn't make that, a rectangle make a shape that makes a rectangle actually is maximizes the area. But if I didn't know that, one way I could do is to look at my table, okay? So if I look at my table, so when you want to mess with these tables, the way you do that is you go second. Watch this because you're going to have to do this. You go to table set in your calculator.
Wait,
Okay?
can you do that again?
Yep. I go second table set, which is above window. All right? And then since Francesco already figured out for us that the maximum is going to occur at 5, I'm going to say, what if I think the maximum is going to occur when x is 4? Okay? So I'm going to start at 4.
How do you know that? Like,
I'm just guessing. Okay, you'll see when we get to another problem, okay, how you know that number, where to start, okay, but right now, and I'm going to set, this means how much do I want to, how close or how much do I want to go up at a time. So in this case, I'm going to set this to 0.1, not point, so I'm going to go like this, okay, and then if I have this set on auto, it's going to generate the table for me. If I set this on ask, then I could plug in different numbers for x. But here I'm going to go on auto, okay? And then I go second table, which is above the graph, okay? And if I go second table, I can see that as I go up in increments of 0.1, what number do I appear to be getting very close to? What number do I appear to be getting close to? I get very close to 25, and then it appears to be going back down again, right? Yes? Okay? So the way you would write this, and then if I got even closer, if I put in a smaller increment, so say I want to do a smaller increment, I'm going to go like second table set, and maybe I want to start at like 4.9 and go up in increments of 0.01. Okay? So if I went up in increments of 0.01, I could get even closer to where I guess my maximum occurs. And you can see that as I get closer and closer to 4.99, I get closer and closer to what number? 25, and then it goes back down, right? Now this isn't exactly 25, even though it looks like it. That's because your calculator is rounding off to 2 digits or something like that. I could probably fix that setting in there, but I'm not going to mess with it right now. Because you can see down here that that's actually 24.99996 rounded off, right? And so the way you would write that using algebra or using limit notation is you would write this like this. Hannah, are you grading now? You're grading, very good. Okay. So you would write this as the limit of f of x as x goes to 5 is equal to 25. So what this says is as I get closer and closer to 5 from either side, my y value gets closer and closer to 25. So what Francesco said, he said this represents the vertex of that parabola, right? So as I close in from either side on this point 5, okay, the y value that I approach up here is what? What's the y value that I approach? 25. When you're looking for a limit, you're looking for the y value that you're approaching as you approach some x value, okay? So moving on, let me show you some more, okay? So this, okay, f of x becomes arbitrarily close to you should probably write this down, okay? As so if f of x becomes arbitrarily close to a unique number L as x approaches C from either side, then the limit of f of x as x approaches C is called L. This is written this way. The limit as x approaches C of some function f is equal to L. Can anyone tell me what the answer to this problem is? Oh. Well, we'll look at it in the table, in a table. You just keep writing that down. I'm gonna grab my calculator. Okay, so say instead of L squared minus, or 10x minus x squared, I plug in 5x minus 2. And delete that, okay? And I'm gonna look at my table close to what number? Someone asked me before, how do you know what number you start the table at, right? Sarah, did you ask me that? Who asked me that? Did you? Who did?
I did.
Okay, so now you know, what number am I gonna get close to? What number do I wanna get close to? 4. What's a number that is close to 4 to the left of 4? What's a number that's close to 4 to the left of 4? Like 3.9, right? So I'm going to plug in 3.9. So you want to go to the left of that number and see what's happening to the left of that number and see what's happening to the right of that number. So I'm going to set this, I'm not going to set it at 0.01, I'm going to just set it at 0.1, okay? 0.1, and then if I look at my table, second table, oh, that's pretty easy, right? What number do I appear to be getting close to as I get close to 4? Hello? 18, right? Does anyone see another way that I could have done this? How else could I get 18? Taken 4, plugged it in, and got out 18. That works for linear functions and polynomial functions and functions where it's not undefined at that point. But a lot of times, there's a function that approaches some value, and it's not immediate. You can't just take the value and plug it into the function. For instance, okay, like this one, all right? So, who wants to guess? Who wants to guess what number I get close to? Who said that? 0. So Francisco says if I plug in 0 in here, I'll get close to a number, I get close to 0, right? So that's what, because what happens if I plug in 0 in here? What do I get out?
0.
I get square root of 1 minus 1, which is 0, square root of, so I get 0 over 0, which is indeterminate. So you can't determine anything from 0 over 0. 0 over 0 is not 1, it's not 0. It's just called indeterminate. So now we're going to explore this function, okay? So using my calculator, I'm going to plug it in. I'm going to go y equals, okay? So this is one where you can't just obviously plug in 0 and get out the answer. So in my calculator, I'm going to put x up here, and go divided by, in parentheses, I need a set of parentheses, otherwise you have to remember there's a parentheses there. So square root of x plus 1, close that parentheses, minus 1, close that parentheses, and then I'm going to look at my table close to what number? Close to what number? 0, because I'm trying to find the limit where x is equal to 0. So what is a number close to 0 on the left side of 0?
-0.
Like negative 0 point, right? Negative 0.01 or negative 0.1 or something like that. So I'm going to plug in here negative 0.01, okay? And I'm going to go up in increments. I'm going to go in increments of 0.00, whoops, I have too many decimal points. 0.001, okay? So I want to see what's happening to this function as I approach 0, okay? So now I'm going to look at my table, okay? 0.01, uh-oh. What? So I'm getting closer and closer to 0. What number does it appear that I'm getting closer and closer to as I approach 0 from either side? 2, okay? Whoa! Francesco, what's wrong? What's happened? We should go tell Mr. Shoup that, okay? So, no, he was just guessing. But, so in this one, I have to look at the table and see what happens as I get very, very close to 0 to see what this value of what the value of this function is approaching. Okay? Or I can also look at the graph, right? If I look at the graph, where's my graph? I'm going to go zoom 6. Zoom, where's zoom? Zoom? Is this zoom? Zoom 6. Okay? So, and from the graph you could kind of see it. If I do zoom in, I could kind of see that as I get closer and closer to 0, do you guys see that it's approaching 2? And if I hit trace on my calculator, okay, so watch this. As I get closer and closer and closer to 0, it gets closer and closer. Uh-oh, what happens at 0? There's a hole where it's undefined, right? So, so this function's kind of weird. Like as I get closer and closer to 0 from either side, I approach 2, but exactly at 0, it's undefined, right? Or there's a hole, or however you want to say that. And some of your calculators will graph the hole. This one kind of shows you that, and we saw that in our table, right? That there was an error when I tried to plug in 0. So that's one case. That's, say, analyzing it numerically, and this was analyzing it graphically and seeing that it's approaching 2 from either side. You get that? Okay? So questions about that? Okay. There's another interesting function. Y equals, I don't have this, y equals sine of x over x. What do you think that approaches? Limit as, so this is one that you learn in calculus. Limit as x approaches 0 of sine of x over x. This actually approaches, you want to check it out? See what it approaches. You guys try it. See what value that approaches. Go ahead. Give it a shot. Try. I'm going to turn off my, it's unplugged, okay? So going back, if I were to try this one, okay? If I plug this into my calculator, let's just do it, okay? I get, you have to put the top in parentheses and the bottom in parentheses. X to the third power, close that parentheses divided by, you got to put the bottom in parentheses too. X minus 1. And then I want to find the limit as x goes to 1. Okay, so I'm going to go second, table set. Second, I said second, table set. And I'm going to plug in a number close to, whoops, I didn't do that right. Second, table set. There we go. What's a number close to 1 on the left side? What's close to 1 on the left side of 1? 0.9 something, right? Like 0.9, okay? And then I'm going to go, I'll go up in increments of 0.01. So you kind of have to play with these to figure out what to put in there. And then if I look at my table, okay, as I get close to 1, what value does this function seem to be approaching? It appears to be approaching 2. And if I got closer and closer, I would. And if I graph this, watch, zoom 6, what shape do I get? Why does this look like a parabola? Because if I divided this into this, I would get the equation of a parabola. I would get an x squared equation everywhere except exactly at 1, 2, right? At 1, 2, I would have a what in my graph? A hole. I would have a hole in the graph, a hole at 1, 2, right? So this is a graph of a parabola. So what the limit says is as I get closer and closer, whoops, I want a different color. As I get closer and closer and closer to 1, I get closer and closer and closer to what y value? 2, right? As x gets close to 1, y gets close to 2. Even though exactly at 1, it's undefined. Yeah? Yes, ma'am?
Would you just write that as like what you have already and then equals 2?
Equals 2. Yeah. So even though if I took 1 and plugged it in here, I get undefined. Okay? So looking at a couple more weird ones, like this one. This is a piecewise function. So let's see it. So if I were to graph this one here, that's not very good. I need arrows on both sides. Okay? If I were to graph this, if you remember piecewise functions, this piecewise function is represented by y equals 4 everywhere except at x equals -3. So this is the line y equals 4 exactly at -1, 2, 3. The function is equal to 0. Okay? So this is your x-axis. This is your y-axis up here. And what this function, this is like y equals this. Okay? So y equals 4, which is a horizontal line, everywhere except at -3. Exactly at -3, the value of the function is 0. So who can tell me what the value of this function is as I approach -3? What is the value as I approach -3? So from either end, what y value am I approaching? Yes, Francesco. The answer is 4. Alright? Guys, get that? Yes. I don't remember how.
4?
So the answer to this is equal to 4 because this says, so this is a, I don't remember how to put in piecewise functions. There's a way, but I don't. So what this says is the limit. So this is a function y equals 4 and y equals 0. Y equals 4 everywhere except when x equals -3. Exactly at x equals -3, it jumps down to be 0. So, but as I approach -3 from either side, even though this should be lined up down here, even though exactly at, if this is the point y or x equals -3, right? As I approach that value, I'm still approaching y equals 4, but exactly at that value, all of a sudden there's a hole there, and it pops down to be, it pops out to be 0. So the limit is 4, the value is 0. Yeah? No? Maybe?
Is that going to be on these things?
Yeah, it's going to be on that test. Yeah, it is. Okay? So, it's not that, but here, let's look at another one, okay? So say I have this one, right? That looks like this here, and then I have this one. And say this is 2, or let's do this. Make this an open circle. Make this an open circle, okay? So they love to do stuff like this. And say this value is 5, and this value is 4. And this is f, okay? What's the limit of f as x goes to 2? What's the limit? What value am I approaching as x approaches 2? 4. It's not 5, right? As I come towards 4 from the left side and the right side, as I come towards 2 from the left side and the right side, I'm approaching 4. I'm not approaching 5, even though exactly at 2, the value of my function is 5. Yeah? No? You'll get the hang of it. It's not. This one, if I were to graph this one right here, what? It shouldn't be a really weird graph. It should just be a line. It should just be a line. Let me see. Did you put it in?
Yeah, I did.
You know how to do it?
Yeah.
Yeah, that one, if I graph y equals, let's do that. Math, whoops, absolute value, number, ABS. Absolute value of x, I want to delete all this stuff. Absolute value of x divided by x. I want this. Oh, come on. Y equals absolute value of x, second, insert, parentheses. Absolute value of x over x. I'm going to do a zoom 6. Is this zoom? Zoom 6. If I graph this function, do you see that function? That's what that looks like.
Yeah.
Okay? That's y equals the absolute value of x over x. And so what is the limit of this function as it looking at the graph? What's the limit as I approach 0 from the left? What number am I approaching? -1. What number am I approaching as I approach 0 from the right? +1. So because that jumps right at 0, it has to approach the same, the definition of a limit says that it has to approach the same value from the left hand and right hand. So the limit is D N E. You know what D N E means? Does not exist. Okay? Does not exist. Okay? Because also if I look at my table, second table, if I look at my table, you can see that, well, second table set, if I set, so I want to look at like close to 0, so -0.1. If I look at my table, second table, I can see that very close to -1, the value of my function is 1. That's because I'm dividing up the positive same number by the same, that's the value makes it positive, right? And then I'm dividing by a negative, which this will always be -1 when x is a negative number. This will always be +1 when x is a positive number. That's why it has that graph where it jumps from -1 to +1, so the limit is DNE. Yes? Questions? You get that? Do you want to go home now? Okay, go ahead. No, you can't. Sorry. What's this? What if I plugged in values for 2? What if I made a table? You can do this in your head. Limit, what's a number close to 2? 1, or why am I doing this again? Let's plug in a number close to 2. What's one number to the left side of 2? What's
1.9.
1.9, okay? If I plug in 1.9, I get 1 over 1.9 minus 1, which I think I would get out, or minus 2. I think I get out -10. Did I get out -10? And if I plug in 1.99, I would get out -100. And if I plug in 1.999, I would get out -1000. I believe that's true. Okay. What? So it goes down, right? This one, if you remember, what do I have at x equals 2? Remember from last semester, what do I have at x equals 2?
Whole.
Not a whole. One of these.
Asymptote.
You have an asymptote there, right? So as I get close to 2 from the left, this graph goes down. As I get close to 2 from the right, as in 2.001, I would get out 1,000. Whoops, yeah, that's right. As I get close a little further away, I would get out 100. If I get a little closer, I would get out 10. If I got a little closer, if I plugged in 2 in there, oh, maybe should that be 1? anyway, but I get out a graph that looks like this. So if you have something like this, you can say that the limit of this also does not exist, because I'm approaching an infinite value. So if I approach a huge number, either negative infinity or positive infinity, that's another way to say the limit does not exist. There's no absolute value, there's no number that I'm approaching as I get closer. It's what? Well, you don't want to say infinity, because from the positive side, we'll get to that, right-hand and left-handed limits. From the positive side, I'm approaching positive infinity. From the left-hand side, I'm going to negative infinity, right? But we'll talk about that tomorrow or the next step.
You still have a hole too.
Not a hole, an asymptote. An asymptote,
Oh,
okay? Not a hole, because, right?
So an asymptote is like a loop?
Well, asymptote is like a what? It's not a limit, it's just a place where the limit does not exist. At the asymptote, the limit does not exist. What?
It doesn't exist.
There is no value, right? There's no value that so what a limit is I can plug in a number and get an answer, right? Or I can see that I'm approaching, and there is no number that I'm approaching. I'm approaching a negative huge number. Or I'm approaching a negative big number. Okay, moving on. Here we go. Oh, if I were to graph this, I just want to show you, if I graph this, okay, you could try it by your own, but if I graph this one, this isn't like y equals sine of x over x. What happens with this one, it kind of goes like this, and you think, oh, it goes to 0, but if you zoom in on this piece right here, what it's doing inside, if I zoomed in, I get this thing that's bouncing around like crazy, like this. And this is another case in which I get d and e. You want to see that? Who wants to see that? That's kind of cool. But so watch this. If I graph y equals cosine of 1 over x. Y equals cosine of 1 divided by x, and I go to mode. Am I in radian mode? I'm in radian mode, and I'm going to go zoom 6. I'm just going to graph this, okay? And it looks like, oh, it just looks like it's about -1 or something like that, right? But if I go zoom in, watch, this is kind of cool. Zoom in. Oh, I wasn't seeing the whole picture there, right? And then if I zoom in some more, zoom in again, okay? This thing is bouncing around all over the place. So as I get closer and closer and closer to 0, it bounces from being positive to negative. Yeah, and if you think about why that's happening, okay, because cosine of a negative number can be either positive or negative, depending on how far around the unit circle I'm going. You understand what? Like cosine of negative 2 pi is going to be positive 1. Cosine of pi, so as I get closer and closer and closer to 0, that number just jumps all over the place. So that's called an oscillating limit. And so that limit does not exist in that case either. Okay? So if you want, you could write this next thing down. Okay? If you want to, you can write that down. You don't have to. You can if you want to. Where's my recorder? There it is. You want to write that down? But I'm just going to kind of, as you guys are working, I'm going to write down some examples of what these things. Uh-oh, what happened? What happened? I'm going to write down what these things mean. So this thing means that the limit of a constant, this means that the limit of a constant is a constant. So the limit as x goes to 3, for instance, of 5 is just equal to 5. That's what this means. So I have the line y equals 5. Anywhere on that line, the limit is going to be 5. this says that the limit of y equals x, I can just plug into that function. So if I have the limit as x goes to -2, -5 of x is equal to -5. This says if I have a power function, the limit as x goes to 2 of x to the 5th power is equal to 2 to the 5th power. Okay? So in other words, I can just plug into these functions to find the answers. That goes for a root function too. So if I want to know the limit as x goes to 4 of the 4th root of x, that's equal to the 4th root of x, or the 4th root of 4. Sorry, there's a lot to teach you, but I'm just plugging away here. You want some time to write those things down? Okay. Sorry, I had to talk at y'all, period, but I know. Can I go back? Yeah. I can go back
Just to the last set, like, the last two properties.
this?
One before that. Yeah, that one.
Okay.
Thank you.
So unfair. Like, I'm not destroying it. I would have been a little bit deciding.
I get a free lunch today. Today is Teacher Appreciation Day.
All right.
Where the heck are my Tootsie Pops?
There.
Yeah, but you're supposed to give them to me today.
Okay.
Teacher
Do you want me to
Appreciation.
get one and give it to you?
Sure. What? Okay, go ahead. I wasn't paying attention to whether you were paying. Here, you can have mine. I'm gonna give it to you.
Thank you.
Okay. Mitch is here. Mitch is here. Do you know where you're running? Are you running tomorrow? Go ahead. You want to?
I know, I do, I just, I
You have
won't
a
be here
test
Friday.
tomorrow. Or you never finish? What? Yes?
Can I retake the test next Wednesday or do it?
Sure. No, you can take it.
It depends on the event. It depends on, because they're all different days.
Oh, is it like, do they
Wednesday
split
and
up all
Friday.
the events?
Yeah.
Like, here's the first half and here's the second half? It's
Well,
not
right,
like,
yeah, and then they also have prelims for some events too.
it's not like field events one day and
Right, it's like some relays are on one day and some individual events.
I won't be here Friday.
Why not?
Why?
You're gonna miss a captivating lecture.
That means you
Okay, just let it know.
Okay.
What, I didn't finish a test? Test did not finish.
See you later, man.
I think I purposely did not finish the test.
Oh, so are we just gonna give up on this one? I thought I had it here. I think Harrison beats Ryan Newton. Who's this? Sarah Mouse. There was the first 9-1 to 9-3 half test. Did you never take this? Great.
I thought
It's why I keep my name on my mouse, see?
Should I grade this?
did I write on it at all?
Yeah, you wrote a lot on
My
it,
mouse.
but you skipped a bunch of problems.
Is that the one that we're retaking, that you're making a retake on, or is that the?
I already have a retake of this one.
Oh, that's the one that I need to retake, and then I'm also gonna retake
Wait, do
it.
you need that?
The second, the
Other one.
last one that we just took?
Yeah,
Okay.
This is my,
Okay.
yeah, just give me a 0 for that.
Okay.
that's not having it then, is it? $20 for this, it's like an $80 mouse.
$20 for that?
$20. 40% off.
That's too much.
That's discount. You got it for free. I have 2 of them as well.
What is it? An ergonomic mouse?
What? I have it now.
What is it?
It's a gaming mouse. Yeah, that he got for free.
I get a lot of them for free.
You know what I want? Hey, okay, here's my technology question for the day. So I watch TV in my basement,
Okay.
but I want to wear wireless headphones. How do I do that?
You just get wireless headphones. Yeah. And plug them into your TV. Yeah. Wireless headphones plug into your TV. If they're Bluetooth and your TV doesn't have Bluetooth, then
You have to get a Bluetooth receiver.
or you could use like a wireless. Do you want to use headphones or a headset?
headphones. I have like wireless, headphones. Bluetooth headphones.
Like you already have headphones?
Yeah.
Oh, I doubt your TV's.
No, it's old school. The most TVs don't have Bluetooth, right?
Yeah, most
Yeah.
TVs don't.
So you have to get a Bluetooth.
You'd have to get, I don't know if they have like transmitters like that.
Yeah, they do.
I assume they do have.
You'd have to get one of the.
You have to get a
transmitters
Bluetooth transmitter.
from audio in or
Yeah.
audio out to.
Okay, I got it. I got it. Okay.
Yeah, just like you were thinking.
I was thinking right.
Yeah.
Okay, we'll get it later.
But